And so we're going to begin again. This is take 2 for this one. My phone cut out for whatever reason. I would be remiss if I did not show you another way to do greatest integer. On the last page, you will notice that method, which I like the most actually, puts one on the x-axis, one segment above and one below, and then you can put your ellipses or you can keep playing the game. The way I'm going to show you now, we'll put one segment to the left, one to the right, and then another one to the right. So let's see what we can do. So here, you simply let this be -1, 0, and 1. And you come over, put the equal to's on, and then for this one, you just less thans, add 1, and then add 1, add 1. Now, when this happens, you plug in -1, and when I plug in -1, my answer is -2. When I plug in 0, my answer is -1. When I plug in 1, my answer is 0. So that's one way we can do it. So I come down here at -1, I'm -2, and I'm open. Then for the next one, I'm at 0, -1, closed, then open. Then I'm at 1, 0, closed, and open. And that's all you need to do. You can do dot, 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 dot. Okay, now you can always keep the pattern going. You can just say, okay, I'm going to come over here and just follow the pattern and keep on going. Some people like to do it. My answer keys, most of them show I've been bored while I'm watching people test. And when you watch people test, folks, it's like watching grass grow. There is just so much excitement. So I will fill them in, so that's pretty cool. You can fill them in or just put the little dot, dot, dot that you're used to for etc. that are called ellipses. You just need 3 of them. You can put as many as you want. And it says the graph keeps going as is. So it's your option. So inside my graph, a bunch of horizontal segments, and we're, again, only doing steps up. Now, I still like to do my analytical the way that I have shown you. So I plug in -3 and I get -4. So here's -4. I do one less is -5. I put in my left and right. My x is positive, so it stays the same. So to the left of -3, it's going to be the answer -5. To the right of -3, the answer is going to be -4. These are not equal, so it's D and E. And f of -3 is just the plug-chug answer, which is -4. So I went ahead and did some extra ones so we could see what happens at -3. So here's -3. As I approach from the left, 1, 2, 3, 4, 5, you can see I'm approaching, I'm at the y value -5, and I stay there. When I approach from the right, I'm at the y value -4. And so it's just letting you see that the graph is indeed showing what will be true. Now, problem 14. I always love this one. College professors like it. What you're going to find out is that this will be a hyperbola, the left branch, hyperbola, the right branch, and a semicircle. I start out with the semicircle. And my semicircle, what makes it 0, 0, and so I have a 4. Square root of 4 is 2, so my radius is 2. So I'm going to go 2 left, and it's open, and 2 right, and it's open, and 2 up is in the interval. And so there's my semicircle. So I'm fine with the left side of -2, and then this is the right side, and then this is the left side, and this is the right side. And so now how would I do this knowing that this is hyperbola? And if you squared it out, you're going to get your answers y squared minus x squared. X squared minus y squared equals 9 when you finish resolving all your issues. And when x squared and y squared have opposite signs, you have a hyperbola. What you've been taught to do is just draw a box here. Well, I can visually see the box. Okay, I don't have to draw it. And what I'm going to do is put in those diagonals as I go through to the center. And those are going to be my asymptotes. And so I would just finish the graph because now it's going to say the equal to's. At 2, I'm going to be 0, so I get to close it up. And I'm asymptotic. And over here I get to equal to, so I'm going to get to close it up. And I'm asymptotic. And there's how we draw our hyperbolic segments, but that's really the top half of the hyperbola and the top half of the circle. And you can see it's nice and continuous. This is a really nice one because we get tired of these. But the left side, you have this. The right side, that's supposed to be a 4. You have 4 minus x squared. I plug in my -2, I get 0. It's 0. It's 0. And the function value's the top one. It's 0. So it's nice and continuous at x equals -2. Over on this side, the middle one is the left side of 2. The bottom one is the right side of 2. These are all zeros. And the function value goes into the bottom one, which is 0. So now I'm continuous at x equals 2. And here's your cute graph. I'm not going to do one like 15 because it's just another absolute value over the stuff inside. So it's going to be similar to number 12 that I redid. So we are now